Arrays are a fundamental data structure in almost every programming language and also in Godot. It is one of Godot's 3 data container types. The intended use of arrays is to store and manage ordered collections of elements. Each item is stored in a specific position, which we call index, and can be accessed or modified using that index. It is important to remember that the arrays always start with 0, and 0 is the index of the first element of any array. Make sure to remember this for later. From 0, the numbers increase until the end of the array. You can also use the indexing in reverse if you use the index from 0 backwards. -1 will give you the element at the end of the array, -2 the second from the back, etc. Now that you understand the structure of an array a little better, you will likely begin to see that they are extremely versatile and widely used for handling ordered data and allow for great optimizations in our script, and greatly help handling and storing dynamically created variables or objects on runtime. But when should we use an array? We use arrays to store and manage multiple related items in a single structure. They are ideal for lists, inventories, collections of objects, and other situations where we need to store data in sequence or iterate over multiple values. Now that sounded all very complicated, but let me illustrate this for you. A great example of this are waypoints that are used for simple pathfinding for the enemies in a tower defense map. We can create a list of coordinates where we want the enemies to rally to, and we can determine the order in which they do so. On the map it looks a bit chaotic, but in the array, which works under the hood, it looks like this. When we let another enemy run, you see that he runs through the waypoints in sequence, just as they have been arranged at the time of creating the array. He is jumping from one element to another. To demonstrate this further, if I were to use the shuffle function of the array and change the sequence in which the waypoints are stored, you see that the enemy now runs all over the place in order to get to the position which comes after the last position he has been at. Hopefully that makes it a little bit clearer. So as you see, you should use an array when you need to store and access multiple items in order, especially when the number of items may change during gameplay. And arrays support a lot more functions than just shuffling the array. They are useful when you need to dynamically add, remove, or process multiple objects or data, like handling a player's inventory or managing a list of enemies. Godot extends the array's versatility even further by allowing us to even store values of different types together in the same array. Though I haven't found a use for this myself yet, so if you know of a good example on how this can be used, help us all learn and let us know in the comments below. Now let us run over some examples in code to see how we can work with arrays. I won't be able to cover all of the functions that arrays have, because as you can see there are a lot of them. But we'll have a look at the ones which I think are the most important. So stick until the end, because it's very likely that you will use them all at some point in your journey by creating games. I encourage you to check out and play with the rest of them one by one as you find the time. It will help you immensely to practice using arrays, and your future self will greatly appreciate it to have learned about all of your possibilities early on. If you have questions about a specific function that I have not covered in this video, feel free to ask about it in the comments below. So how do we use arrays? Let's remember the part about indexing from the intro. Elements in arrays have an index that represents the order in which they are stored inside the array. Creating an array works just as creating any other variable. So we start by writing the var. I call it my array, and I equal it to some empty brackets. This has already initialized an empty array. You can also give the array some predetermined values, which for example in my case would be 1, 2, 3, 4, age separated by a comma. Yet arrays can hold a real lot of different types of values. So in this case, I could even create an array out of arrays. For example, taking my array that I already created before and the another array. And now we have an array consisting of 2 different arrays. And as we said before, we can even store mixed values or mixed types inside of an array. So let's do that. we create an array with a bool. For example, this one is true. Then we pass it a string. Then we give it, then we give it, for example, an enemy that I have already set up a class for. And what else? We can give it a float, for example. Now that is all good, but it also bears some risk. To an array, I could basically add everything that I want. So to make it more type safe, what you can also do is specify what you want to store inside of that array. And we do that with the semicolon, as with all the other data types as well. Call the array, open some brackets, and inside here I can write, for example, what I want to have inside. Int for integer, float for floats, or only enemies. Yeah, so the possibilities are many. Now let me take these away so we have a clearer focus, and we work with the two arrays that we have up here. To access an element of an array is easy. Just remember what we said about indexes at the beginning of the video. First, we call the array. In this case, I will take another array. And in the brackets, we give the index number that we want to call on. In my case, it is the 0 for the first element, which is 1. This might be a little confusing, so let me change that real quick. We call it 1. So if I were to call the index number 1, that is the second element of our array. 2 is the third, and so on. If I call the -1, then we go from the back. That would be 4. And if I take the -2, that would be the 3. And we can check that is true if we use the print function, and we will print our another array. And we give it the index of -2. Just for the funs, I will also do the same thing. Copy, paste this, and give me the 2. And they should both print 3 because index 0 is 1. Index 1 is the word 2. And index number 2 is the word 3. So in this case, -1 and -2 and 2 actually point to the same element. We run this. And indeed, both print 3. However, we should be careful when we use indexing like this. For example, if I were to print something which is outside the scope of the indexing of my array, for example, we have 0, 1, 2, 3. If I want to print the index number 4, we will have a problem. Because in this array, there is no index of number 4 and your game will crash. So be on your toes about that one. And we would see later how to iterate safely over an array without overstepping its boundaries. Good, so what we have seen here is how we can access an array's element. What we'll do next is change some values. And that is pretty easy. We can just take our another array that we had up here, and at the index of -2, which we said is the number 3, we can now assign it something else. For example, we can give it the number, we can give it the string of 5. If we print this again, that which previously was 3 now is 5. You can also print our whole array. And what we'll see is that 3 has been exchanged for 5. Now let's see how can we add values or delete values from an array. And there's a lot of ways that you can add values or delete values from an array. Let's first start with our push front function that we have. So we have push front and back, and they basically do the same. Just so you see, in the front, I want to push a new value in. This will have the index 0. So I will name this 0. And I also want to push something into the back. And that is going to be last item. And now I'm going to print the array to see what we have changed here. And as you can see, we have 0, which we added at the front. And we have last item, which we added at the back. And that's also a way to insert an item. And here, though, we would have to give him a position where we want to insert it. For example, I would like to go to the index position 3. And I want to insert here, for example, the number 10. So printing this again will now give us the 10, which is at index position 3. 0, 1, 2, 3. Great, I hope you're holding up so far, because now it gets a little bit more complicated. Let me just clear our text box down below a little bit. And what we will do now is we will delete items from our list. So let's begin with the pop functions. We have the pop add, we have another one that is called pop back, and we have another one which is called pop front. Pop add is basically the same as our insert, and he wants us to give him the location where we want to pop something out. For example, I could take the 10 out again if I tell him to pop at the number 3. Pop back and pop front are doing exactly what we expect. The pop back delete the last item that we have, and the last item that we have and added is the last item, and the pop front will delete 0. So if we print then our array again, it is pretty much cleaned up to almost how it was before. Now you see 0 vanished, the 10 vanished, and also last item got deleted. One thing to keep in mind though is that the pop-up function can do a little bit more. It is actually not only deleting an item, but it also returns the item before it deletes it. So what we could do is to work with this pop-add function. We could, just to make it simple, use the print function on this, as in accessing this one, and it should print us now 10 before it gets deleted. And indeed, it prints 10, but afterwards it is not there anymore. There are other functions which can be used to delete and erase values, which one is the erase and one is the remove add function. Now remove add and pop add are basically the same, only that pop add can actually return something, whereas remove add does not. So if we remove the third item, this is going to delete our number 4, and erase is a bit special because here we can actually erase an element by finding it by its value. So let us print our array one more time, and you can see that now we actually made a mistake. We don't have 3 elements that we can call by index to remove anything. We have the index 0, we have index 1, and we have index 2. Calling the index 3 should normally result in the program breaking, but luckily our remove add function, if the index is out of bounds, this method just fails instead of breaking the code. So we got lucky this time. Please keep in mind that with all these functions that we remove something, Godot itself writes ourselves a warning that they should not be used to erase elements while iterating over an array. It is just not supported. Yeah? And what will happen is that if you erase something while iterating over an array, you will reduce the size that it calculated preemptively, and he will run out of bounds and the program will crash because he will try to access more indexes than indexes that are left. But we can try this out in a moment. Just for now, if you want to quickly erase all the items inside of an array, you can do that by calling the another array.clear. That is one thing that clears all your array. Or what you can do is also just take the array and assign it an empty array. And like this, you have cleared your whole array. We can print this again because we love printing arrays. And off we go. We will see that the array now is empty, just as expected. So quite a lot of things that we have done now. Let's imagine we have this empty array and we want to populate it. Yeah, my another array is currently empty. And I want now to populate it by copying a different array. Let's make that real quick. Let's say that we call it different array. And we give it the values of 1, 2, 3, and 4 again. And I would just say you will have the values of different array. And printing now my another array will give me the values that are inside a different array. Actually, I must have mistyped this. Okay. This is not the way you should do it though. We have the numbers, this is great, but now if we now were to take our another array and we will take the index position 0 and reassign it to 5, you will see that if we print our different array, so the one that we have just fed it to, we will also have changed the values here. See? So we are printing the different array. We have changed the value on another array, which is a different array, but still different arrays value of 1, which was at the index position 0, has changed to 5. And the reason why that is also documented inside of the Godot documentation. Arrays are always passed as a reference. If we really or truly want to have a duplicated array, then we would have to tell him to please duplicate this array instead of just passing it as a reference. If we play the same scene now, what you will see is that everything works as we expected. Our duplicate array has not changed. Instead, our another array indeed has changed to the value of 5 at the beginning. Here we go. And this is the output that we would expect. So keep in mind, if you are copying arrays, you have to use the duplicate function. But also here, you have to be careful. If you have an array containing arrays, what you would want to do is a deep copy. If you would just copy the different array as a duplicate like this, you would still only pass the arrays that are inside this array as a reference, which when you change those, then things get complicated. Luckily, it's very easy to make a deep copy. You just have to write true in here. If you have any questions about that, check out the documentation. If you click on Control and then click the duplicate, it will directly take you to the array method that explains it more in detail. So let's call this here copy of array, and perhaps let's comment out all of these print functions. Okay, cool. This has been fun so far and I hope you're keeping up, but now we come to the juicy parts. We want to start iterating through an array. And we can do so by two means, either by for loop, which is the recommended way, but it's also possible to do so with a while loop. So let's cover that as well. So first let's start by using the for loop. We write the for I in, and then we pick our array that we want to cycle through. So what I is an element of our array, and he's going to cycle through all of the elements that this array has. I starts at the index 0 and goes upwards to the index of 1, 2, 3, etc. So if we go and we print simply I, you will see that it's going to print our elements that we have in this array one by one. Here we go. I know this little for loop looks very puny and simple, but don't go underestimating its potential. I will show you how I used iterating through an array to basically relocate all of these x's inside of the positions up here in the array like this. And it is still a pretty simple example. First, what I did was initialize an empty array. Then I would call a get waypoints function, which is down here. And to my empty array, I assign the result of what is the get children. Get children will return you an array of nodes. Now I have an array of nodes, and this array I iterate through, and for every element inside of that array, I call a function they have in the script, which is called moveSprite, and I gave that a position where I wanted to move to. And this is yet a simple way to use it. It shows though how powerful it is to just iterate through the elements of an array with very few lines of code and make them change all the position at once. Now let's move on. You can also use while loops, and I'm not quite a fan of it, but here we have a beautiful example of using the function of the size. So first of all, what we would have to do is we need a counter, which we equal to 0. And while the counter is smaller than the array.size, and the .size is returning how many elements we have inside of our array. And while this is true, we want again to print, and this time it's a bit different on how we access our array. We would print another array, open up the brackets, and we would pass the counter this time as the one which is showing the index number which we want to access. So counter is going to be 0. We start at 0. And after this is done, to not end up in an eternal looping state, we would say counter will be plus equals 1. So this way we can loop through our array using the .size method. But also the .size can always return just the size if we need to know how big our array currently is. And since we already have this while loop, why don't we take the my array, which is sitting at the top still as an empty array, and we will add some values to it. Append is doing the same, not aped, append. So append is doing the same at the push back. So it ends an element at the end. Let's take, for example, our another array counter, and we will add 1 to it. And also what I would like to do is for every time that we add something, we are going to add something else, which is going to be the value 3. So we will have multiple values of 3. And when this all is done, I want to print my array to see the values that we are holding. And you see we have the value 6, 3, 3, 3, 4, 3, 5, 3. Now this is great because for the next thing that I want to show you is a function which is called count. Let me give you a glimpse of inventory management, how you can use that there. For example, everything inside of our array can be seen as an inventory. For example, we have the 3 multiple times in there. If we want to know how many times we have the 3 inside of our inventory, we can just call the myArray.count function. And we pass him the element that we want him to find and count. Now, if we print all of that out, that means he's going to print us how many of this element 3 do we have inside of our array. And there we go. It is 5 times. Now this number can be pushed into a label, which is attached to the sprite in our inventory, and you would have already represented how many pieces of that item you have. Now one of my absolute favorites is the option to pick a random element of our array. And that is easily done. So to abuse our print function again, we can just say print, take my array, and then we use the pick random function. And what this will do, it will pick a random element out of our array. Now the chances are high that we're going to pick 3. So let's increase the chances that we get other numbers as well, and let us see what happens now. So we have 5, 3, 3, 5, and 3. So at least 2 were picked, which were not 3s. Great. I'm happy with that. But I don't quite like how disorganized my array is. I want these numbers to be in sequence so that I have all the 3s at the front and the 6 at the back. This can be done by the sorting functions that we have inside of Godot. So sorting an array is also a very important part of what you can do with them. And for some cases, as with numbers, that is already very easy by just calling the sort function. Imagine how easy it can be. Now we will print our array to see if it's indeed sorted. Run again the code. And we see that indeed it has been sorted for us. 3, 3, 3, 3, 3, 4, 5, 6. Sometimes though it could be more tricky and maybe you don't want to sort numbers. So for that case, what you could do is also call my array and say sort custom. And then what he expects you to do is pass him a function that you create. So basically a callable. And I will call this sort my array. So let's create that real quickly. So my function, which is called sort my array. And I want to reverse the case of sorting it ascendingly, but I want to sort it descendingly. So I give him 2 parameters, which he is taking. These are the elements that he's passing in, A and B. And then I want to check if A is greater than B, what I want to do is return true, else he's going to return false. So after we've called our function to sort our array in the reverse order, we will, you guessed it, print my array. And let's see, it is indeed the reversed order. Last but not least, what you've seen in the beginning was also the possibility to shuffle around an array. That is done by myArray.shuffle, as easy as that. For the last time, now let's print the array again and see that now it's scrambled up. Not as much as I would have expected it to, but you see the result. If you want even more about arrays, I will go through a specific example for arrays in a future video where I build a target prioritization system for games like TDs, where the player can choose whether the nearest, the weakest, farthest away, strongest, or just a random enemy should be attacked. If you want to stay tuned for that one, subscribe to not miss it. Thanks for watching, keep creating games, and see you in the next one.